question I'm going to solve on this video is going to be 9f, which asks you to solve this inequality that has an x in the denominator, which makes it a little bit tricky. There's two good ways of solving this, and I'm going to do both ways. So alternative 1 is going to be to sketch the graph first, and alternative 2 is going to be a bit more algebraic. A sketch is always a good idea, so we can see what's going on. We're going to sketch y equals 1 on x plus 3. We're going to ask ourselves, when is that graph less than 2? So y equals x plus 3, that's a hyperbola. It's a hyperbola that's shifted left 3. So it looks like this. These are supposed to be approaching and not touching these asymptotes here. So there's our graph. Now we're asking ourselves, when is that graph less than 2? Well, 2 is somewhere up here. So when is that graph less than 2? When is the y value of that graph less than 2? Well, over here, it's definitely underneath 2 there. So they're all x values that are less than minus 3. And it's also less than 2 here. So we need to know what this point is, because it's less than 2 from that point onwards. So we need to work out the point of intersection. So let's work out our point of intersection. Well, we just need to solve when 1 on x plus 3 equals 2. Or in other words, when 1 equals 2x plus 6. Or 2x is minus 5. X is minus 5 on 2, or minus 2.5. So that point has to be minus 2.5 there, which makes sense. And this graph is under 2 whenever x is bigger than minus 2.5. So once we sketched the graph and we knew that point of intersection, we could just read our answer off the graph. So our final answer is that 1 on x plus 3 is less than 2, well, when x is less than minus 3, or x is greater than minus 2.5. Now we could write that in set notation. So x is in this interval from minus infinity up to minus 3, union, because it's or, from minus 2.5 up to infinity. Okay, so the graph is under 2 for that whole section there. So a graph is a good way to go to see what's going on. There is a second alternative, and that is to multiply by the denominator squared. So in this case, x plus 3 squared. Multiply both sides by x plus 3 squared. Now, you're probably asking, why don't we just multiply by x plus 3? Because that would get rid of the fraction, and that would be quite nice. The reason we can't do that is because we don't know what x is. So x plus 3, we don't know whether that's positive or negative. If it's positive, we wouldn't flip the sign, and if it's negative, we would flip the sign. So we can't just multiply by x plus 3 because we don't know if it's positive or negative. I can multiply by x plus 3 all squared though, because I know that's always positive, so I'm not going to run into trouble there. So if we multiply both sides by x plus 3 squared, we're going to get x plus 3 is less than 2x plus 3 all squared. Now this is essentially a quadratic inequality. To solve this, we want to bring everything to one side and use a little bit of a graph of a parabola to work out when the inequality is true. So if we bring everything to one side, I have 2x plus 3 squared minus an x plus 3. I can factorize an x plus 3 out. That'll leave us 2 of those minus a 1. It's not equal. It's greater than. So this is an x plus 3, and that's a 2x plus a 5. So we really want to know, when is 0 less than this? Or, in other words, when is that greater than 0? That's probably easier to see. So when is this greater than 0? Well, that little parabola has intercepts of minus 3 and minus 5 on 2, that's minus 2.5. It looks like this. When is that parabola greater than 0? Well, it's greater than 0 here. That's when x is less than minus 3. And here, that's when x is greater than minus 2.5. So we can see that we get the same answer. So hence, 1 on x plus 3 is less than 2 when x is less than minus 3 or x is greater than minus 2.5. Again, we can write that in set notation, saying it's in the interval from minus infinity to 3, union the interval from minus 2.5 all the way up to infinity. So at the end of the day, we still kind of need to do a little sketch, but it just happens to be a parabola, right? This kind of is just a means to an end to solve this quadratic inequality here. It's not particularly related to the original hyperbola that was in the question, okay? But it's an alternative. We multiply by the denominator squared, and we simplify the algebra to get to a different inequality, which we can solve in a different way. Both methods end up with the same answer.